So our second last topic in this unit and our last lesson for this outcome is looking at the discriminant. So you should have already done the activity kind of exploring the discriminant, but we're going to beef it up and really put some words to what it can implicate about a quadratic equation. So in general, our quadratic formula is x equals minus b, or negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. So that's a pretty beefy equation. And to punch that in multiple times, and remembering the fact that we actually have to do two calculations, one with adding and one with subtracting, that can be pretty time consuming. So we've noticed over time by doing a number of calculations with different quadratic equations that there's actually some parameters that can create some rules that we can follow so that we can learn about our quadratic equation without having to apply the entire quadratic formula. So the discriminant is what is under our radical. Okay, and when we calculate just the discriminant and we find that it is bigger than 0 or positive, that's another way of thinking about it, then we can say that there are two real roots because we're going to have to both add and subtract the value once we calculate the radical. When the discriminant is equal to 0, well, then the square root is 0 as well, so we actually only end up with one possible value for x, and that's negative b over 2a. Finally, we can run into scenarios where our discriminant is less than 0 or negative. In that case, and you may have noticed this in our activity, whenever our discriminant was negative, there were no real roots because we cannot take the square root of a negative number. So we can apply these kind of three parameters to figure out how many roots are there actually in each quadratic equation. So I believe we're missing the question here. Something happened to my formatting, but we're going to determine the number of roots. Okay, so for this first example, we've got 3x squared minus 5x equals negative 9. Before we can actually start plugging into the discriminant, we need to get this into general form. So again, set equal to 0. Always need it set equal to 0 for general form. We've got 3x squared minus 5x plus 9. Now I can plug into my discriminant a, b, and c. So that's going to be negative 5 squared, because remember it's b squared minus 4ac. So negative 5 squared minus 4 times 3 multiplied by positive 9, which gives me 25. And that's 36 times 3. So technically I don't need to finish this calculation, but I will, or maybe we look at this as 12 times 9, so that's 108, which is negative 75, 83. Because the discriminant is less than 0, that means that I can't take the square root of it when I put it into my quadratic. That means that I have no real roots. So it's a little funny. Okay, so it all comes down to this value and how does it compare to 0? So if we look at the next equation, we've got a, b, and c, we're going to plug them all into my discriminant. So again, b squared minus 4ac. It's not a bad idea to always write out your equation before you start plugging in. It's going to be negative 3 squared minus 4 times a fourth multiplied by 9, which is 9 subtract 9, which is 0. Because it is actually 0, that means that there will be one real root. If I had ended up with a positive number here, then I would be in a scenario where it was 2 real roots. So that just, and when I talk about real roots, all that means is that when I go to graph this equation, in this particular case, I'm only going to have one x-intercept. So it's either going to be opening, I know it's opening upward because my a value is positive, so it's going to be somewhere along those lines. Whereas this graph, it's opening upward, but because it has no real roots, I can safely say that it actually won't touch my x-axis at all. The last question we come across here is determine the value of k so that we know that it has 2 real roots. So we're already stating the parameters. We set the parameters and then we're going to have to work within that realm. So 2 real roots implies that my discriminant, which is b squared minus 4ac, must be positive, must be bigger than 0. From here, we can actually manipulate this inequality. So I'm going to plug in a, b, and in place of c, I'm going to use k because I don't actually have a number to go in there. So it's going to be negative 5 squared minus 4 times 3k is greater than 0. So 25 minus 12k is greater than 0. Now at this point, you're like, okay, I need to isolate my variable. You've got 2 options. Either you can subtract 25 and move it onto the other side, or you can add 12k and move it onto the other side. I personally am always going to default to making my variable positive. So in this case, I'm going to move that term that actually has k in it. Now the reason that I'm doing this instead of moving the 25, I'll make apparent and kind of explain once we've done the math. I'm going to add 12k to both sides. And so that leaves me with 25 is greater than 12k. Divide by 12. And we get k is less than 25 twelfths, or 2 and 1/12, whatever way you want to think about it. I'm just going to leave it as an improper fraction. Okay, so that includes all possible values of k. Now, if I had done it where I moved the 25 instead, I would have ended up with a statement, negative 12k is greater than negative 25. Then I would have had to divide by negative 12. When we change signs, we actually change their order. So if we consider on a number line, that's 0, we're talking about -1 or -2 compared to -5. And then we go on to the other side of the number line and we talk about 2 versus 5. Well, -5 is less than -2. But when we change their signs to, or keeping it in the same order, +5 is greater than +2. So by changing the signs, I actually have to change my inequality. So whenever I divide by a negative, I have to flip the inequality the other way. So I do still get the same answer, But by moving my 25 instead of moving that negative 12k, I then introduce another place where I can make a mistake and forget to flip my inequality. So that's why I prefer the first way that we did it. You can still do it this way. You are more than welcome to move the 25, divide by negative 12. You just have to remember that when you divide by negative, you have to flip your inequality. Okay, so you've got some practice questions to kind of wrap your head around this whole idea of what exactly the discriminant is. I can pretty much guarantee you that you're going to see a question like this D part where I give you the parameter and you have to solve for a variable on an assessment. So be comfortable with this idea of moving this around. Do some practice questions that involve starting with the parameter and solving for what kind of variables would have to be present in order for this to happen. Okay, so give it a shot, and then that's actually the end of R4. So congratulations, you are done.